Hi everyone, welcome to Tech Tales with LR. It's a beautiful fall day today, and let's learn something fun. In today's video, we're going to explore process versus thread, and we're going to look at multi-threading and multiprocessing in Python, look at the code, and try to run it locally and see how it works. Let's begin. A process and a thread are both independent sequence of executions. A process will contain multiple threads. The major difference between the process and the thread is that the process will have separate memory and the thread will run in shared memory. Okay, now let's look at the code. Let's look at multiprocessing process. In order to create new subprocesses, I'm using this module. The way to create a process is by providing a target, and we can also pass in the arguments to the process here. Here I have created two methods. One is add 100 and give it to the next person. What basically this is doing is just printing the process by using the OS get process ID method, and it's also going to put 100 into the queue. In addition to that, I have also declared another method. It's called double it and give it to the next person, where I'm putting 200 into the queue and printing the child process ID. Here in the main process, I am using a special variable called multiprocessing queue. Because a process is independent and it cannot share memory, we need to provide a shareable variable or a shareable multiprocessing queue in order to share the memory. As you can see, the method that I have declared here, I have added as a target to the first process and also added it as a target for the second process. This is the method that gets run when I say first process dot start and second process dot start according to the configuration that we have provided. Next, what I'm doing is using a join method. What join method does is it's going to wait for this process to finish triggering. Whatever is in the function here, it has to finish running, only then it'll move on to the next one. So the second process, it's the same thing. Whatever is declared here should finish, and only then the program will continue. Here, I have a try and except block where I'm trying to read the value from the MPQ that we declared and then try to print that value. Whenever the multiprocessing queue is empty, it's going to raise an exception. In order to gracefully handle it, I'm just using try except block here and trying to print the total time that's taking this whole program to finish running. Okay. And now let's run this, run Python file in terminals. Okay. The major important thing that I want you to take note in this output is the parent process ID and the child process ID. Here we can see that the parent process ID number is this, and there are two different child processes created. We can also see that we can read the values in the queue together in the main processes here. And we can also see the time it took for this to finish running. Now let's look at how we implement a similar thing with threads. I have the same methods that I declared before for process. I have the same code where we are trying to get the child process and we are trying to add a value to the queue. Here, as part of double it and give it to next person, I'm adding 200 and end in the queue. And as part of add 100 to the add 100 and give it to the next person, I'm adding 100 in the queue here. Okay. In the main process, I am creating a new thread by using multi-threading package called threading. And this provides us this thread to constructor to declare target and args, similar to how we created process in using multiprocessing process. This is the method that gets run when I run the thread.start, and thread.join is also the same way that it waits for the program that's declared in this function to finish. If we don't provide this, the order of the output is going to change a little bit. Major difference is in process sharing. Previously, in order to make the two process share values on the memory, we needed to create a multiprocessing queue. Here, we can just use doubly-ended queue and then add a value there. If you see, we're just adding a value into the queue here. And then in order to read the values, we can just pop left and then print the values. I'm doing the same exact thing, but the major difference is in how the memory is being shared. Here we're using doubly-ended queue, and in the previous example, we used a multiprocessing queue to be able to share values. Okay, now let's run this in Python terminal. Okay, as you can see, the parent process is the same and the child process is the same. Okay, and it took it almost this time for it to run. Okay, so there you have it. A process creates new process ID values, whereas the thread is created as a subset of a process. In process, we cannot share the memory, so we needed to use a special variable called multiprocessing queue. In thread, we can share memory and we could straight use doubly-ended queue, and we were able to access the value in the main thread. In today's video, we looked at multiprocessing and multithreading and also the code. That's an old way of creating threads and process. There is a different method called concurrent.futures, thread pool executor, and process pool executor. We will look at that in my next video. Software engineering is all about building fun user experiences using technology. I hope you learned something fun today. See you in my next video.